Okay, guys, in this lesson, we're going to learn about a system of linear functions. We're going to learn how to solve by graphing as well as an algebraic method of substitution and also elimination. So a system of linear equations is simply two or more equations working together to find a solution. The solution to a system is the point and ordered pair of where they intersect on the graph. This ordered pair will make both of the equations true once you plug them into each equation. So let's get started. Let's talk about the three types of solutions. Notice in our first example, we have a one intersection. So that means we have one solution to the system. We have two equations, two graphs, and they intersect in one point at -1, 1. And this means that this is the only point that they have in common. If I plugged -1, 1 into each of the equations, if I were given them, I would have two true statements. These equations have different y-intercepts, and they definitely have a different rate of change, a different slope. So please take note that when you have exactly one solution to a system of linear equations, the y-intercepts are different and the slopes are different. Now, let's talk about infinite solutions. Infinite solutions means that the equations are actually the exact same. They have the same slope and the same y-intercept. They coincide with one another. You can't see the green line because it is exactly the blue line and it's lying underneath. So every point on both of these equations or both of these graphs would make the equations true. Next, we have no solutions. Notice these two lines. They are running parallel. They will never intersect. That's why there is no solution to this system. When you have a system that has no solutions and you have parallel lines, what makes it parallel is they start at different y-intercepts and they have the same rate of change, up 1 over 1, up 1 over 1. The same for our green line. We're going up 1 over 1, up 1 and over 1. They will never intersect. So there is no ordered pair that they have in common. Therefore, there is no solution. Let's take a look at one special system that has one solution, and these are a system of perpendicular lines. I want us to notice the slope. It's all about the slope. So you can see that the slope of our green line is -3 over 2. I'm going down 3, right 2, down 3, right 2. And the slope of the other line is +2 over 3. So all perpendicular lines have opposite reciprocal slopes. One is positive, one is negative, and then you can see that they are reciprocals. This would tell me that these lines, if I didn't have a graph, I could identify that these are perpendicular and they intersect at one place and intersect, creating a 90-degree angle because they have opposite reciprocal slopes. So let's solve by graphing. This is going to be very easy because you've already learned how to graph a linear equation. The main thing is that your y is isolated and it's written in slope-intercept form, where we have our slope and our y-intercept. So we're simply going to graph each of these lines and then identify where they cross on the coordinate plane. So let's get started. Here's our first example. We have equation 1 and equation 2. They're not in slope-intercept form, which is y equals mx plus b. So let's isolate the y. So we're going to subtract 7x from both sides. And we have -2y is equal to -7 times x plus 8. We're going to divide every term by -2. And we end up with y equals a +7 over 2x minus 4. Let's go ahead and graph that. We're going to start at 0, -4. we're going to go up 7. 1, 2, 3, 4, 5, 6, 7. Into the right 2. 1, 2. I'm going to go one more time. 1, 2, 3, 4, 5, 6, 7. Into the right 2. Do my best to draw a nice line. Okay, the next one I want to change colors, and let's see if this green will show up. So we're isolating the y. Let's subtract x from both sides. We have 2y is equal to negative 1x plus 8. We're going to divide every term by 2. And we have y equals negative 1 over 2x plus 4. We're going to graph. We're going to start out at 4. Our slope is down 1 into the right 2. And I can already see that that's the point they're going to share. But let's go ahead and go down 1 into the right 2 one more time. So nice line all the way through the points with arrows on the end. So you can see our solution is the point of intersection, which is 2, 3. That's the solution. And this ordered pair is the only ordered pair that will make both equation 1 and equation 2 true if we were to plug in those values. Example 2. So here it's in slope-intercept form, so let's go ahead and graph that. We're going to start at 0, 2. Our slope is going down, so we're going to go down 1, 2, 3, and to the right 1, 1, 2, 3, and 1. I can also reverse the slope and go up 1, 2, 3, and left 1. And so there's this line. And now let's solve this other equation. So we're going to subtract 4x from both sides. We're going to divide by negative 1. We have a positive 4x minus 5. So we're going to start at 0, negative 5. We're going to go up 4, 1, 2, 3, 4, into the right 1. 1, 2, 3, 4, into the right 1. So you can see that point of intersection is right here. And that is point 1, negative 1. The one ordered pair that makes both equations true. Let's again isolate. We're going to subtract x. And let's go ahead and graph that. So we're starting at 0, negative 1. We're going to go down 1, right 1, down 1, right 1, or up 1, left 1, up 1, left 1. And now let's solve this one. Minus x, minus x. I have y equals negative x minus 2. I want to start at negative 2. And I'm going to go down 1, right 1, down 1, right 1, up and left. And you can see, even without graphing, I could have noticed this algebraically because we have different starting points with the exact same slope. You can see these are parallel, so there is no solution. And example number 4, this is in slope-intercept, so we're going to start at negative 1. We're going to go up 5, 1, 2, 3, 4, 5, and over 1. Let's go down 1, 2, 3, 4, 5, and left 1. That is so not straight, but you get the point. That's why I usually try to do several ordered pairs. Okay, now let's solve for this one. Minus 5x, minus 5x. We have negative 3y is equal to negative 5 over x plus 3. We divide by negative 3. And we get y equals, this is going to cancel out the negative, so 5 over 3x minus 1. We're going to start at 0. Look, their starting points are going to be the common point, the intersection. So we're going to go up 5, 1, 2, 3, 4, 5, and over 1, 2, 3. Down 1, 2, 3, 4, 5, and left 1, 2, 3. So here, the y-intercept is the point of intersection. So that's going to be 0, negative 1 is my solution for both equations. Both of these are in slope-intercept form. Fantastic. Let's start at 0, negative 6, and go down 4, 1, 2, 3, 4, and right 1. I'm going to plot another point on the left, 1, 2, 3, 4, and 1. So here we go. Now, we may need to do more definite points for when we do our next graph, but we'll see, or our next equation. So we're going to start at 0, 7, and we're going up 1 and right, 1, 2, 3. I can see it's not going to cross over here, so I'm going to go down 1 and then left, 1, 2, 3. And that looks like where it's going to intersect, but just to make sure, let's use our slope and plot a few more points. So my slope was down 4 and right 1, or up 1, 2, 3, 4, and left 1, 1, 2, 3, 4. Yes, that is the point of intersection. So this ordered pair is going to be -3, 6. This is the point that makes both equations true. This is the solution to our system. Okay, now we're going to do an activity, and let's watch this video, and it shows how to use Desmos. So we're going to insert our equation. We are going to then create a new equation. Make sure when you're if you have a fractional slope, that you arrow out and make your x not be in the denominator. And then you're going to go to copy it and then make it into a function table. So you're going to be able to see it in the table, your solution in the table, as well as on the graph. So if you need more points, you can just enter new x values, and you can see right here, this point of intersection is not like a nice, neat integer. And if you just click on it, you can see the decimal answer for your solution. So this is using Desmos as a graphing tool, which is fantastic. So you can just open to desmos.com, and then you can practice this. This will be a graphing tool that may be used on the EOC coming up in April, so it's good to get familiar with the tools. So let's turn the page. And again, you can just play around with this, and you're just going to use your wheel here, your settings wheel. So once you type in your equation, y equals, and it does have to be in slope-intercept form, just make sure that you type it in, and if you have to use a fraction, such as this second one, that you arrow out and put your x beside it, not in the denominator. And then you can see the lines cross here. And what I did is I also just copied the equation and then clicked the settings tool and looked at the table of values. And my table of values, my inputs are integers. And because our solution was not an integer, then I could just use this tool and click on the intersection, and you could see it shows your solution. So 3.2, 2.4 is your solution. So for these next examples, if you would just log on to Desmos, the graphing calculator, and it's just desmos.com. You can see it here, just desmos.com, and then you can do \calculator, or it will ask if you want the calculator. And please just play around with this. So if I want to put y equals, if my slope was like 3/2, 3 and then the slash, and it makes a denominator of 2, but then arrow out, and I'm going to say x, and then we can say like +1. And then if I want a new equation, I have to click enter. If I wanted to see the table of values, I could duplicate this just so I could keep my equation in front of me. And then on the next one, here's my table of values. And if I wanted more order pairs other than -2 to 2, I click on this 2 and then click enter. And then if I wanted to click above and get like -3, I can just type that in here. Okay, and so just play around with that. And here are the practice problems. Let's get back to our PowerPoint. So if you will pause and write these down, and then, like I said, use your Desmos, and just wherever they cross, this will be your solution.